So in this experiment, you're going to build a gnomon. What is a gnomon? It's any object that casts a shadow. For our experiment, we need the gnomon to stand exactly vertical and to cast a shadow onto a nice flat horizontal surface. So my gnomon is just a ruler that I've attached to a heavy box with some elastic bands. And the sun's not totally cooperating with me right now, but you can see that it does cast a shadow. Now when it comes to gnomons, bigger is better, so a 30-centimeter ruler like this is the minimum. If you've got a longer one, that would work better. If you've got a long pole or something that you could drive into some grass beside a sidewalk, that would work even better. So a larger gnomon will give you more accurate data. Now what you're going to do to take data is you're going to be measuring the length of the shadow that the gnomon casts on the ground. But you have to take your data in a specific time period during the day. We're trying to find true noon, which is the time when the sun is highest in the sky. And that's going to vary depending on the time of year and also on where you're located east to west inside your time zone. So people in different cities will measure true noon to be at different times. So starting at 11:30 standard time, or if it's daylight savings time at 12:30, you're going to take data every 5 minutes of the length of your shadow for about an hour. So it'll be from 11:30 to 12:30 standard time or 12:30 to 1:30 daylight savings time. You'll take data every 5 minutes of what the length of your shadow is. What you would find after you're done taking all your data and recording it in your book is that one of your shadows will be the shortest. That shortest shadow is the one that happened at true noon. So you'll take that length of the shadow when it was shortest, so the length of the shadow at true noon. You'll also take the exact height of your gnomon, and using those two quantities, plus something that you look up called the declination of the sun for that day, you're going to calculate what your latitude is. In other words, where you're located on the surface of Earth relative to the equator. Once you've got your latitude, you'll compare it to the known value for your city with a percent discrepancy. Now, one thing to be careful of, especially if you're using a shorter gnomon, like a 30-centimeter ruler, is that you do need the exact height of your gnomon above the ground. So this is a 30-centimeter ruler, but I've got these little bits of wood at the end of it, so you need to measure those too. So for example, you'd come in here with another ruler and say, okay, that's about 3 millimeters. And over here is about 2 millimeters. Therefore, the actual length of my ruler is 30.5 centimeters. So that would be the exact height of my gnomon. If you're using a post driven into the ground, then you want to measure the exact height above the flat surface that you're measuring the length of your shadow on. Likewise, if you're measuring the length of the shadow by bumping the end of your ruler up to your gnomon, again, remember that little bit of wood at the end and take that into account in your measurements also. So try to be as exact as possible, especially with these shorter gnomons.